Hello and welcome back. So today we're talking about cognitive biases and heuristics. So they're similar to the informal fallacies in that they're ways of thinking, ways of reasoning, ways of arguing that don't guarantee truth. They're not truth preserving. They're a little different from the informal fallacies. You notice many of the informal fallacies had Latin names because they'd been around, they'd been recognized for centuries. Um, the cognitive biases and heuristics, uh, many of them have been discovered in psychological experiments in the last 50 years or so, uh, and they tend to reflect ways our brains process information that's not necessarily bad in specific contexts, right? So the way sort of evolution works is it's just the quickest way to basically reproduce, right, and preserve your genetics. So often you don't need a rigorous form of argumentation to do that, to stay alive long enough, to feed yourself and feed your children so that they can go on and reproduce your genes. So there's all sorts of little shortcuts in our brains that get us the right answer enough of the time, right? Um, but if you take them out of very specific contexts, they tend to give you the wrong answer. So again, this is sort of repeating what I just said. Biases and heuristics are also fallacious, right? They're tendencies to reason in ways that don't give us a good reason conclusion. But another difference with some informal fallacies is that they happen unconsciously. Sometimes you don't even know that you're doing reasoning. You don't even know that you're making an argument when you engage in a cognitive bias. It's so much of it is just automatic. So that means that sometimes the reasoning involved will be even less explicit than in informal fallacies, right? And already we notice some of the premises or the conclusion were not necessarily stated explicitly in informal fallacies. Everything's even more implicit sometimes in these cognitive biases. Um, we didn't get a chance to do the Wason selection task, but when I will, right, try to make that happen. If we have to do it online, I could maybe figure out a way to do it. But it's one of these studies that demonstrates um, how it is that people can be very good at deductive logic in very specific instances. In the case of the Wason selection task, it turns out if you're trying to catch people who are cheating, um, people are very good at that, right? If someone's breaking the rules. But if you take that and make it a more abstract task, people tend to fail reliably in certain parts of the task. So I'll try to make a way that you can actually try the Wason selection task and understand what I'm talking about there. So the first cognitive bias we're going to consider is called confirmation bias. So confirmation bias is the tendency to accept information that exists, the beliefs you already have, and then ignore or discount information that conflicts with the beliefs you already have, right? So, we all have some beliefs in our head floating around. Um, Many of them are unconscious, right? So if I asked you, uh, what was the name of your elementary school, you could probably recall that and tell me that's stored somewhere in your brain, even though you weren't consciously thinking about your elementary school. So we have a lot of information just stored there, right? And confirmation bias says if it's already stored in your brain, you're going to tend to want to keep it there. And if there's information that comes in that suggests that the stuff you already have stored is wrong, you're going to try to ignore it, right? So, you know, not all the beliefs stored in your brain are true either. Some of them are false, right? So just to take an example, suppose that I believe I'm the greatest guitar player of all time, right? That happens to be a false belief. There's many people that are better than me, right? Or, maybe I believe that climate change is real. That could be a true belief, right? Confirmation bias can happen either way, right? So sometimes it'll function to preserve your beliefs that happen to be true, and that's great, except that it's not a reliable process because if that belief you had stored happened to be false, confirmation bias would have protected that belief as well, right? So again, it's not so much about whether your existing beliefs are true or false. It's about is the process reliable? Does it reliably produce truth? And here it doesn't. It just conserves whatever happens to already be in your brain. So here's an example, right? Take my belief about my guitar playing abilities. Again, let's suppose the belief is I am the greatest guitar player of all time. So the way confirmation bias works is as information comes in, I'm going to weight the evidence differently, right? Which is not how it should work, right? As evidence comes in, right, you should weight all the evidence equally and adjust your beliefs based on the new evidence, right? But what happens in confirmation bias is I don't do that. I'm selective about the evidence and how I weight it. So if somebody comes by, they hear me playing guitar and they say, hey, you sound great. I'm going to latch onto that. I'm going to weight it heavily. And I'm going to use that to support my existing belief that I'm the greatest guitar player of all time, right? But if somebody comes by and says, hey, you sound pretty good. You should hear my cousin, though. My cousin is amazing, right? Um, I'm going to not treat that evidence the same way I treated the previous evidence, right? I'm either going to weight it less or I'm going to ignore it entirely, right? That's how confirmation bias works. It can also work in that I'll interpret evidence differently depending on whether it supports my belief. So say I'm practicing, right, and I'm practicing the solo to Stairway to Heaven, and this time I nail it, right? I'll say, look, it's evidence, right, that I am the greatest guitar player of all time, right? And I'm going to really take that evidence to heart, right? But now let's say I'm practicing the solo, and I mess up. Well, I might say something like, oh, you know what, I had a headache, or I heard a sound, I got distracted, right? And I'm just going to sort of shove that evidence to the side, right? So another way of treating evidence unequally when all evidence should count the same. It might even work with my memory, right? I might tend to remember events that support my belief more, and I may tend to forget ones that don't, right? So that person that came by and said, hey, you're pretty good, but my cousin is really great, a couple days down the line, I might even forget that that incident even happened, right? Whereas I might tend to latch onto and remember the person that said, hey, you're really great. Confirmation bias also affects our evidence-seeking behavior, right? So I might go out looking for evidence that favors my belief. I might ask people that I already know are going to give me compliments. Hey, what did you think of that solo, right? And if there's somebody that I know is, they're probably going to be more critical, I'll just avoid talking to them altogether. This sort of active evidence seeking happens a lot in the sort of news people seek out, right? So you may notice in our society, there's conservatives tend to read Fox News, which tends to give them conservative information, conservative talking points. Liberals will tend to read, I don't know, they'll watch maybe CNN or read the New York Times, and that's going to give them stuff that supports their beliefs, right? And so we do this all the time, and it's just not a reliable way. It's not an accurate way to weigh evidence. Right? So here's an example of, an actual experiment that demonstrates the confirmation bias exists. So I'll sort of summarize all this text. You're welcome to read it. It's in the textbook as well. Uh, so what they did is they took undergraduates at a college somewhere. That tends to be the bulk of the subjects in psychology experiments because, they're nearby to the lab and they're willing to work for relatively cheap. So this experiment was done on undergrads. And what they did is first they gave them questions asking about their beliefs in capital punishment. Do you believe the capital punishment is moral? Do you believe that it's effective in deterring crime? And based on the students' responses to those questions, they separated them into two groups, right? So they found a group of people that tend to believe in capital punishment, and they found a group that tended to not believe in capital punishment, right? And once they found their two groups, they then gave them scientific studies about the effectiveness of capital punishment. And they messed with them a little bit to make them different, right? So the studies were the same, but the conclusions were different in each case. So in one of them, it concluded that capital punishment is effective, right, and does deter crime. And the other one concluded the capital punishment is not effective. So they gave these studies to members of each group, right? And what happened was confirmation bias. So, for example, if you were a student in the group that already believed in capital punishment and you got a study that concluded that capital punishment is effective, people tended to say, and then later the researchers asked, hey, was your mind changed, or did this support your beliefs, or did it undermine your beliefs? And people say, no, it supported my beliefs. And they ask, what did you think of the study? Do you think it was well done, or was there problems with the methodology? If the study agreed with your existing beliefs, they said, great study, well done, and now my belief in capital punishment is even stronger. But what do you think happened if someone got a study that conflicted with their beliefs? Well, if they already believed in capital punishment and they got the study that said capital punishment is not effective, they tended to say, that didn't really change my beliefs at all. And also, I think that study was actually kind of crappy, right? I think there were some problems with it, right? And it wasn't just the people who believed in capital punishment, right? The other group that thought capital punishment was not effective, same thing. If they got the study that agreed with them, they said, wow, great study, it bolstered my belief. If they got the study that disagreed with them, and again, the study is exactly the same, they only changed the conclusion. They said, oh, terrible study, right? And no, it didn't change my mind at all. And so exactly what we've been saying, right? You get in different kinds of evidence or get weighted differently depending on whether they agree with your pre-existing beliefs. That's confirmation bias. The next bias is called zero-sum bias. So zero-sum bias is the assumption that any benefit to some person will be a deficit to another person, right? And sometimes that is the case. Some situations are zero-sum, right? So if I bring in a pizza to class and there's only 8 slices, then that's a zero-sum game, right? If there's more than 8 people in the class, then if one person gets a slice of pizza, that means another person doesn't, right? And that is the case with some things in life. But the problem is not everything is like that, and we have a tendency to assume everything is like that, right? So, one place that zero-sum bias tends to come up is in arguments against immigration, right? So you'll often hear opponents of immigration saying, well, if an immigrant comes and gets a job, they're taking it away from someone who was born in this country. Um, and, maybe there are points in history or areas where that turns out to be the case, but economies are so complex that you can't just assume that it's a zero-sum game, right? It could also possibly be the fact that lots of immigration will tend to boost the economy and create more jobs, right? And there's more for all to go around. Certainly that's been the case at some points in history. There may be other cases where it's more zero-sum, but you can't just assume that everything's zero-sum off the bat. And again, this can be demonstrated in game theoretic experiments. So game theory is a kind of psychology where they study people's behavior, their economic behavior, or just their behavior in competitive situations, right? So this chart up here is just the outcomes of a particular game. You don't need to know the details of the game, but basically these options A, B, and C are different strategies that these people could use when they're playing the game, right? And you'll see, depending on your strategy, your group will get a certain number of points, the other group will get a certain number of points, and there'll be some difference between the groups. So if you look at these 3 strategies, it's clear that strategy A would give your group the most points, right? And you would get the highest score. And what they find is that even if, that's the goal is to get the most points, people will tend to favor a strategy like C, right? Now, in C, your group only gets 18, so you're not getting the most points possible, but you are beating the other team by more, right? You see on the option C over on the right, the point difference, there's an 8-point difference between you and the other team. And people subconsciously and automatically tend to choose strategies that hurt the other person more based on the assumption that if I'm hurting them, I'm helping myself, right? And vice versa, right? If they're helped, then I'm hurt, right? So people tend to avoid a strategy where maybe everyone does well, right? That doesn't even occur to people because of zero-sum bias. So here's another study that demonstrated zero-sum bias. This was with grades at a university. So once upon a time, this was even before I was at a university. People would curve the grades so that look, there can only ever be 10% of the grades can be A's. There have to be 10% F's, and there have to be a certain amount of C's. And they would sort of again curve everyone's grades to match that curve so that it didn't matter how high you scored, the only way you got an A is if you're in the top 10% of the class. I don't know of any universities that do that anymore, right? So it's always possible now. So that was a zero-sum situation, right? There was only a limited amount of A's that were going to be handed out. Nowadays, it's not zero-sum, and in my class, if everyone does great, then everyone gets an A, right? And if everyone does terribly, then everyone gets a bad grade, right? But it's not zero-sum anymore. But they found in the study, right, that students tend to assume that there's a zero-sum situation going on in the background. So they would watch different presentations and they would see the grades that people would get. And if they noticed that a lot of A's had been handed out, and then you ask the students, hey, what do you think the next grade is going to be? They tended to say, oh, it's probably going to be a low grade, right? So they're assuming that there's a limited supply of A's, right? When that's not the case. Again, zero-sum bias. Next bias is called availability bias. So how availability bias works is we tend to overestimate the prevalence or probability of an event when it's easy to remember, when it's like present, ready to mind, right? So for example, plane crashes, right? Plane crashes are extremely rare, right? Particularly compared to car accidents, right? You're overwhelmingly more likely to be involved in a car accident than ever in a plane accident, right? But if you ask people how likely are plane accidents compared to car accidents, they tend to way overestimate the possibility of a plane accident or a plane crash. Why is that? Well, plane crashes are so rare and so dramatic that every time one happens, it's in the news. So you've probably heard of every plane crash that ever happens, right? Because it shows up in the news. Um, Also, it's very dramatic. It's indelibly printed on your memory. You may have yourself, imagine what it would be like to be in a plane crash. It sounds pretty horrific, right? So all of those factors make plane crashes very easy to remember, right? And so we tend to overestimate how probable or how prevalent they are. Um, this might be an example of why people buy lottery tickets. So the odds of winning the lottery are practically zero, right? You're more likely to get struck by lightning than to win the lottery, right? Um, but when someone does win, right, it's big news. It's all over the news. So and so won $1 billion in the lottery, right? So that makes sense that people would spend money on something they're almost guaranteed to lose, right? Because of availability bias, because in their head they heard of someone winning the lottery, and therefore it seems to them more likely than it actually is. Now, confirmation bias and availability bias can work together in sort of mutually reinforcing ways, right? So, if I only seek out information that supports my beliefs, then information that supports my beliefs is going to be more readily available to mine, right? And so then availability bias is going to kick in, and I'm going to overestimate the prevalence. So, this happens with people's perception of crime. Often, even if crime statistics are going down, um, if it bleeds, it leads in the newspapers, right? So people are reading about crime. Also, if they're, reading conservative newspapers that tend to focus much more on crime, then they're going to have a lot of crime going on in their head, and they're going to assume that crime is out of control, even when it's in fact going down. So here's a study that demonstrated availability bias in people. So here they use celebrities' names, right? And they manipulated how famous the celebrity was, right? So they got a list of 39 names, right? And they said, just read these names of celebrities. So in some of the lists, um, there were 19 super famous women and 20 less famous men. So, you'd have Nicole Kidman on the list and, uh, right, Margaret Thatcher, right, uh, Hillary Clinton, some really famous female names. And then the men's names might be less um, well known, right? I don't know, you know, John Bonham, uh, whatever, Robin Hitchcock. These are some musicians that I like that maybe not, they're certainly not as famous as, Hillary Clinton, right? So that's the idea. So they read the list, and then they had another list that was reversed. So the men were super famous, but there were less of them, and there were 20 not so famous women, right? Okay, so the subjects are asked to read the list, and then afterwards they say, so how many uh, men were on the list, right? Which like sorry, they were asked like, were there more men or women on the list, right? And as you might guess, right, when the names were very famous, right, when the men were very famous, they said, oh, there were more men on the list, right? When the women were very famous, they said there were more women on the list, even when there were actually fewer women or actually fewer men, right? So again, it's availability bias. The famous names stick in your brain, and so when they ask you, oh, were there more men than women, you sort of start recalling names, and all the famous ones are going to come to mind. You're not going to remember the less famous ones, and you're going to say, oh, it was more men, right? Even when it wasn't more men, it was just the men were more famous. Um, Similar, right? More evidence of availability bias, right, when it comes to crime, which I already uh, uh, mentioned here, right? People tend to, the the more severe, the scarier crime stories stick in your head, and so people overestimate, the sorts of the severity of crimes and the frequency of crime. Okay, the next bias, implicit gender or race bias. So implicit bias is a different thing than just overt racism or sexism, right? So some people are just racist or just sexist, right? And they don't, they're conscious of it, right? And sometimes even open about it. Um, this is a different sort of phenomenon. This can occur in people that would never admit to being racist or even think that they are racist, and nonetheless, their brain makes certain calculations that have racist or sexist effects, right? Um, and it happens through stereotyping, right? So we have to stereotype to get through life, right? We have to make generalizations, and they're not all false or bad, right? So, if I take the bus a few times, I take the train a few times, and my bus trip is annoying and long, and the train trip is much nicer. I'll make a generalization, say, yeah, trains are better than buses, right? Okay, that's not like that's a generalization, a stereotype. It might even be wrong, right? I might have just had some bad bus trips, but at any rate, it's not harming anybody, right? Um, other stereotypes. Men are on average taller than women. That's true, right? It's a stereotype. It's a generalization. It also happens to be true, and there's nothing particularly terrible about it. Um, but we will observe other correlations, right? And we might make mistakes about when we make these generalizations, right? So you might notice that there's not a lot of black people in the National Hockey League, right? Um, you might conclude from that, oh, I guess black people aren't good at hockey. Well, that's one explanation, but it's not the correct one, right? The correct explanation is it's just hockey is a sort of sport that requires an ice rink, and there tend to be fewer ice rinks in predominantly black areas, right? So your sort of stereotype of a hockey player is somebody like Wayne Gretzky here, like a white Canadian sort of person. Um, but again, it's not because white Canadian people are better at hockey necessarily innately. It's just there's other reasons for that generalization. So implicit race bias, we'll focus on some gender bias that's been demonstrated in some studies, right? So one, they noticed, so between the 70s and the late 90s, the way that people audition for orchestras, like the violins, the cellos, right, and the horns, the way they audition changed from somebody just walking out on the stage and, the people that the hiring committee sitting there watching them play to what they call blind auditions, where they put them behind a curtain so that the people judging them don't know who is playing, right? They just hear them. So the idea was that was to avoid sort of favoritism. Maybe your student is auditioning, or a friend of yours, or a relative, um, and they wanted to avoid favoritism in that way. But it turned out that what ended up happening was more women started getting jobs, right, in the orchestras than they used to before, right? And so they wondered, geez, was there implicit gender bias going on here, right? So a woman would come out, play the cello, and people would rate her competence, and maybe somewhere, even if they didn't think of themselves as sexist, um, their brains were causing them to rate the women lower than the men, right? So they did check the hypothesis, because who knows, there could be other reasons, right, that the women were getting um, better scores and more jobs after they switched to blind auditions, right? And they checked all those alternate explanations, and none of them seemed to be working, right? So maybe just more women were applying, right? If more women apply, then more women will get hired. Turned out that wasn't the case. Maybe more women were graduating from the top schools, and if you got more women in the pool to be hired, then maybe more of them will be hired. That turned out not to be the case. Um, so it did seem like switching to blind auditions increased a woman's chance of getting hired in an orchestra by a lot, right? So it seems like, unless they can find another explanation, right, which that's always possible in science, it seems like, yeah, implicit gender bias was going on there. We've seen other studies that demonstrate this too, right? If you hand out resumes to hiring managers and say, hey, who would you rather hire? And the resume, two different managers, the resume is the same. They just put a woman's name on one and the man's name on the other. They tend to want to interview the men, right? So again, seems like there's some implicit gender bias going on there. And similar things can happen, with race as well. Okay, on to the next cognitive bias, and we're not going to cover every single cognitive bias that exists right now. I'm trying to keep the list, manageable to the sort of thing that you can remember, on a quiz and an exam and stuff. So we got a couple more left. So the Dunning-Kruger effect is interesting. So it's a tendency for people who don't know much about something to overestimate how good they would be at it, right? And people who know more tend to even underestimate their own abilities, right? So, for example, I don't know if you've never um, uh, built a wall with bricks, right? You might think, oh yeah, it looks pretty easy. What, you just stack the bricks, you slap some mortar in between. I could do that, right? And you've asked people, how good do you think you'd be at building a wall? People will tend to say, if they've never done it before, I think I'd be great. Um, so it sort of makes sense, right? If you don't know anything about it, or sorry, the latter part makes sense. And then if people who actually have some experience and who have tried to build a wall for a while, then they'll start to kind of realize, oh, this is actually really hard. I'm not really so good at this, right? And so you see this curve up here, right? You start out thinking with lots of confidence, and there's a big valley when you learn a little bit, and you realize, oh, I'm actually pretty bad at this, and you may even sort of underestimate your abilities, and then it sort of like creeps up and levels out, right? Um, but there's a big jump of overconfidence in the beginning, right? Um, so in that big jump of overconfidence sort of makes sense too. If you don't know anything about the thing, then you don't know how hard it is, right? And it might just appear easy just looking at it, especially if you're watching an expert do it. They make it look easy, right? But again, whatever the explanation, experiments have shown this effect over and over. So there's the first one is in like a logic, a grammar, or a politics class, right? So they, at the beginning of the class, you give the students a survey. You say, how do you think you're going to do in this class? Um, and most people who don't know much will say, oh, I'm going to do great, right? And then they learn a little bit about it and they realize, oh no, not so much, right? Not so great. Similar thing with medical students, right? You ask them, hey, how good are you at drawing blood? Well, before they do much drawing of blood, they say, I'm awesome at it. And then the more they learn, the more they'll even start to underestimate their own abilities. Right? So, kind of like, in a sense, the dumber you are, the smarter you think you are, sort of thing, is the Dunning-Kruger effect. Okay, last two biases. Now, these last two are so similar, right? The Knobe effect and what I'm going to next call attribution bias. That, on exams and stuff, I'll sort of combine them to be practically the same thing, right? So we'll call it Knobe/attribution bias. It's fine. But the Knobe effect goes something like this. So here's a scenario that that Joshua Knobe, he's a philosopher, an experimental philosopher and psychologist, he gave this to members of people in the study, right? And he said, here's a scenario. The CEO of a company is sitting here in his office. Well, here we have a she, right? Sitting in her office. And the vice president of research and development comes in and says, hey, we've got this great new program we think we're going to start. It will help us increase in profits, and it's going to harm the environment. And the CEO responds, I don't care about harming the environment. I just want to make as much profit as possible. Go do the project, right? And so the program is carried out, they make profits, and the environment is harmed, right? So they then ask people, so did that CEO intend to harm the environment, right? Um, and they'll tend to say yes, right? Now, what the CEO actually said is, I don't care about harming the environment. I don't care either way about the environment, right? But they attribute a negative intention to this person. Now, the interesting part is when they give um, the reverse scenario. So again, same CEO, right? Vice president comes in, he says, we're thinking of starting a new program. It'll help increase profits, and it's also going to help the environment. And the CEO says, same thing. I don't care about the environment. I just want to make as much profit as possible. So they carry out the program, profits are made, and the environment is helped. Now you ask people, hey, did the CEO intentionally help the environment? And sorry, I switched the slide too fast. But this, right, the participants in the study say no, it wasn't intentional. So notice the CEO was the same in each case. The CEO said, I don't care about the environment. I just want to make profit, right? Well, when he doesn't care about the environment and it's harmed, people say, oh, he meant to hurt the environment. But if he doesn't care about the environment and it's helped, they say he didn't mean to help the environment, right? So again, the same thing is going on in the CEO's head, like, I just don't care. But depending on the results, people will either attribute negative intentions, right? They will tend to attribute negative intentions and they will withhold attributing positive intentions. So the whole thing with Knobe and attribution bias is we have a tendency to want to put attribute negative intentions to people when the situation is ambiguous, right? And that's what attribution bias is here, right? So uh, this is a game theoretic experiment. So you've got people playing a game where they like spin a wheel, and depending on what color it lands on, you either lose money or make money. And you're in a different room than the other players, but sometimes the other player is allowed to, instead of spinning the wheel, just put the wheel on a certain color, right? So you're in the other room. You don't know if the other player is spinning it or just putting it on the color, right? But if the outcome is that you lost money, then and you ask people, what do you think's going on in the other room? People will tend to say, oh, they put that on the color on purpose, right? They assume that the other person has negative intentions and that they're controlling things, right? When in fact, in that it's often just random, right? So again, we'll just sort of combine Knobe attribution bias into a more general tendency to attribute bad intentions to people, right? So, you're walking down the hall and someone bumps into you. The tendency is not to say, oh, it must have been an accident. The tendency is to say, right, that person is trying to mess with me, right? Or you're driving around and somebody sort of swerves and you think, geez, that lunatic was trying to hit me. Well, maybe not, right? Maybe they just dropped a cigarette in their lap or something, right? But we tend to attribute negative intentions uh, more often than there truly are. Okay, so those are all the cognitive biases and heuristics that we're going to cover in this class. If you're interested in this, there's lots more that you could research, but try to get familiar with those. Look at the homework. The homework will consist of, examples like this, right, that are designed to, describe a bias, or there may be no bias, right? It may sort of look a little like a bias, but actually be not biased, right? And then I'll be asking you to, identify which bias is going on and explain it. All right, I will see you next time.